We certainly can think about times 9 as being a combination of the times 3 and the times 6. So in the previous video of 3 and 6, we can think about that doubling the times 3 to get to the 6. We also can add on another set of times 3 to make the 9 group. So that is one way we could think about it. Of course, we also could think about times 5 and times 4 to make the 9, those decomposition pairs being so important. But a really major, powerful relationship for times 9 is to relate to being one group less than times 10. Our students can relatively easily get to the times 10s. So we can think about our 9s as being one group less than that. That will extend to anything times 9. We also can extend that to anything times 19 or 29 or 99 or 999. The power of this strategy is through the roof. So again, we're connecting times 9 to times 10. Let's see what this looks like as we explore it in a visual way. Let's take a look at a variety of manipulatives that allow the students to visualize what's happening when we multiply by a 9 and to relate that powerfully to multiplying by a 10. I see a lot of students when they try to practice the strategy of multiplying by a 10 and then removing a group, they forget which number to remove. Is it the 9 or the other factor? So you have to build that understanding with these visual ways of seeing it. Now, I've mentioned supertizing a few times in these videos, and supertizing again is telling at a glance how many are there without having to count. Now, that works not only for whole numbers, but also with fractions and decimal amounts. And here, as we're moving into multiplication, seeing the equal groups. Now, using a 10 frame that's familiar to the students to help work on now multiplication supertizing images, if we had this 10 frame full of these 5s, then we know it would be 50. But 9 groups of 5, we're going to be removing one of those 5s. I have that visual support to see it's 1 5 less. That way that I know that it's, rather than the 50, which would be full, I know 9 groups of 5 must be the 45. And that is such much more efficient thinking than the skip counting by 5s starting at 5. Now, as students are beginning to do that, you might want to encourage them to at least start at the 25, that 5 groups of 5 is 25. You can skip count from there. But of course, our destination would be on the way to mastery to be able to relate this to the multiplying by a 10 and take away one group. Now let's take a look at it again with Cuisenaire rods. So I've got this time 9 groups of 8, which can look pretty scary to some students with those large factors. Now I've separated these Cuisenaire rods out to show you 10 groups because our brain can supertize the 5. If I had them all stuck together as one big rectangle using these manipulatives, you would have to count the 10. So there are 10 that are there. And so if I know that 10 groups of 8 is 80, well, then if I remove one of these, that must be 9 groups of 8. It's 1 8 less than the 10 groups of 8. So here's where our pairs of 10 make such a difference, that 10 groups of 8 is 80. So 9 groups of 8 must be 72. And how can I know that without counting back the 8? I can think about 8 and 2 make a 10. And that is going to always work because that pattern with our 9s is wonderful. Now we can move on to look at this beaded number line. Now within the Braining Camp app, you have the 20 beaded row, but I also want you to imagine this being 100 beads. This can be really helpful, a nice concrete way before you go to number lines, which are a little bit more abstract. So let's take a look at 9 times 2. So 9 groups of 2. So this entire row of beads is 20. So if I were to think about 10 groups of 2 is 20, well, then 9 groups of 2 must be 2 less than that. And I know that this must be, well, first of all, I can see this being 10, 15, and then 3 more, which is the 18. But I also can think about, well, 2 and 8 make a 10. So I know this must be 8 more than that 10. So of course, the 9 times 2 is the 18. But again, I'm visually seeing why this works. And then I can extend this on a 100 beaded number line. That's a straight line of 100 beads, multiplying all the single digit facts by 9. Now I'm going to move to the number line right now to show you that. So you can certainly first have that concrete beaded number line, then we can go to the abstract number line itself. So 9 times 7, 9 groups of 7. I can think about, well, 10 groups of 7 would be 70. So 9 groups of 7. If I built that images with subitizing to know it's 7 less than that, well, then I can move over one of my arrows here and I can adjust it to be the 7. And I can see that I land on the 63. And again, we're also noticing this pattern that 7 plus 3 makes a 10. So I'm landing on a number whose ones place value combines to make the 10. So again, so 9 groups of 7 would be then that 63. And finally, I want to show you the future impact of this. Let's say we go to a 19 times 15. Now, when students have begun learning about these relationships between numbers, it's not limiting to them to the basic facts. They'll have that confidence and disposition to know they can try to figure it out, to use what they know to help figure out what they don't yet know. And so their confidence builds, they're willing to even try it. So in 19 by 15, I have found students who have memorized their math facts and are thinking about it in terms of algorithms. They would tell me, I can't do that. I haven't learned 2-digit by 2-digit yet. But students who have gone through this journey of learning about these math facts through these strategic ways might say, well, 19 is pretty close to 20. And I can figure out 20 groups of 15. I know 20 groups of 15 is the same as 2 groups of 15 times 10. Remember, we're not adding a 0. We know it's a shifting place value, and we're putting a 0 for the tens position in these whole numbers. So that a 20 groups of 15 must be 300. And so 19 groups of 15 must be 15 less than the 20 groups. And so I know I can be landing here on my 285. Very different thinking process than to go through the algorithm, which is just those basic math, single digit math facts. And too often our students are skip counting them. So I want to help move them into this multiplicative reasoning, and it will extend to, again, larger numbers, working with decimals. It's just crazy powerful relationship between 9 groups being 1 group away from 10 groups.